Jeremy Ellis here, maker of rockdata.com. In a couple of months I have to teach a robotics course, and I've always disliked the water analogy for circuits, so I'm trying to come up with something better. So here's a battery, positive terminal, negative terminal. Here's an electron leaving the negative terminal. It'll eventually go this way. And here's a positive hole leaving the positive terminal. Physicists have always considered the conventional current going this direction. Chemists have always thought the electron flowing this way. And neither group really wants to bend to the other view. So what I've done is I've combined both. This beam here is the amount of voltage, kind of like a torque, a lever that moves up. Let me just show you it working. So the electron's flowing this way. The electrons are spinning in a leftward format. Well, I guess we'd have to talk about it as counterclockwise. Positive holes coming out of the positive terminal, going this way, the conventional current, which most physicists talk about. Here it's going through a resistor, and friction or whatever, turning, whatever is slowing it down. And that's your basic circuit components. And the water analogy does an okay job of this. But I like this, the spin, right-hand rule. This positive hole is spinning clockwise, and the electrons are spinning counterclockwise. Now let's look at something with bigger voltage. Now it's going faster, but pretty much the same sort of thing. That's why you have to learn a bunch of math to figure out the current, how fast it's going, the voltage, the resistance here. Same kind of idea. The electrons are flowing and turning and spinning, a magnetic field spinning around them. Your positive holes, I've got them splitting inside the battery here. These are 3D things. The electrons actually go through the holes. It's easy to draw on a board. Now, what if the resistor is not as bent? But here I've got low voltage, here I've got high voltage, moving much quicker. Now, here's the 120 volt. That shouldn't be plus, that should be hot. But notice now it's changing directions. The positive holes are flipping back and forth. So now let's start talking about semiconductors. There are P semiconductors, which you can think of as having sort of more positive holes. There are N negative semiconductors, which would have sort of more electrons in them. But what I'm interested in right now is a diode, where they put a P and an N together in line in the circuit. In this case, it's the positive going this way. So here we have a positive outside the diode, which these things repel each other. So this positive is going to repel that, pushing it across the diode. This electron coming from the other side is going to repel that electron, pushing it across the diode, allowing the circuit to go. It's going to be quite different when we reverse the polarity. Well, let's just watch this. Pushes it, and now current flows. That's pretty much what a diode does. It allows the current to flow. But here we have a different arrangement. Now we have, I've switched the polarity. So we've got the negative here, so we've got an electron going into the positive part of the diode, and we've got a positive hole entering the negative part of the diode. Well, the problem here is these attract. And also these attract. And so what you're going to end up with is a situation in which these electrons and the positons are attracted, there's a gap, there's no flow. And that's the basic concept of a diode, that it is one directional. So now let's get to a transistor. Notice the diode was P and N, and the transistor just has another P, so positive, negative, and positive again. Let me line these up nicely. So, same kind of situation. I've simplified this quite a bit. So we've got electrons going in to the N part of the transistor. This is the logical gate. That electron is going to push this electron towards the positive hole. From this side, we've got positives, which are going to push that positive hole towards the electron. That will make it work. Now here we have a negative part. This electron is going to pull that positive hole, and it might not work. But what we find happens is, as soon as this circuit works, that kind of opens up this negative part of the transistor, and this part flows as well. So what you have is a small circuit here turns the switch on, and that's pretty much what a transistor does. Let's have a watch. What's going to happen? See if, there. Okay, are we going? There we go. So, looks a bit confusing, but what we have is this little circuit turns on the transistor for this bigger circuit to work. And I must admit, this looks a little confusing to me too. Okay, so now, what if we reverse the directions of everything? Now if I have a positive here, it's going to attract that electron, and if we have a negative here, I switch the polarity right now, a negative there is going to attract that positive hole. You've got a big gap in here, nothing flows. So here our transistor doesn't allow the current to flow through the transistor, because this is now switched to positive. So transistors can allow a large current flow using a smaller circuit right here. Okay, let's move on, see what else we have. Oh, I'm just going to finish up with something that's kind of lame. It's a coil, 120 volts, hot. We've got our spinning. I'll talk about that a little bit more for the next video.